Hey guys, what's electromagnetic radiation and why is it important? Okay, so EMR, or electromagnetic radiation, is basically a spectrum of what we call electromagnetic waves to communicate different things in our universe. So you know about sound waves, like you can hear those. And what sound waves are mechanical vibrations in the air. Electromagnetic waves are very different. Sound waves can't travel in space because there's no matter to travel through, but electromagnetic waves can. So the question is how can they travel but sound can't? The whole premise with electromagnetic wave is that it's kind of it's kind of a source of radiation, and it travels at the speed of light, so it doesn't decay with time because it's actually kind of frozen in time. So let me clarify all of this. So there's a spectrum of electromagnetic radiation. There's a radio wave, there's the microwaves, there's the infrared waves, the visible light, there's ultraviolet, X-ray, and gamma ray. So those are all the types of electromagnetic waves that exist. Radio waves that which you use for your cell phones, you can listen to the radio. Those are the weakest type of waves, and they can travel the farthest. That's why we use them. They're the weakest, so they can pass through us and not really do anything serious. We hope, at least in terms of brain cancer and all that stuff. But then there's gamma rays, which are the strongest and would obliterate us. So you can kind of see there are different types of these waves. So a radio wave can travel very far because its energy is not easily absorbed by something. So when you have like a wall, the radio wave just goes right through the wall, and the wall doesn't absorb any of the radio wave's energy. So the radio wave just keeps going as if it didn't see anything. That would not happen with the gamma ray. The gamma ray would just would some of the energy in the gamma ray would get absorbed in the wall as it obliterated the wall, and then it would keep going after that. So um, all these different types of waves travel at the speed of light. The speed of light is kind of misleading. This because the speed of light, it really should be like the speed of electromagnetic waves. Light, as I said earlier, is kind of in the middle of that electromagnetic wave spectrum, but in reality, all of these waves are traveling at the speed of light. They're all traveling at the same rate, and that's why they actually are what we call like frozen in time. So if, as you know from Einstein's relativity, the faster you go, relatively the slower time is for you. And if you go at a fast enough rate, then you won't experience time itself. So that rate that you have to go at is the speed of light. Now, another caveat with Einstein's laws are that when you go faster, your mass relatively increases, which sounds really weird, but your mass increases more and more until you get to the speed of light. And so that means that the light can't have mass, because if it did have mass, it wouldn't be able to go at the speed of light. It's kind of a conundrum. Basically, to go at the speed of light, you can't have mass. So that's why electromagnetic radiation doesn't have mass, but it has energy. Make sure you understand that. And energy can be converted into mass with E equals mc squared, but that's a different topic. So electromagnetic radiation is really important because it is the fundamental signaling mechanism that we all use to communicate to our satellites in space, to make phone calls, and we even use it on like our microwaves and stuff, or we use it to see things. It's the fundamental basis for a lot of things that we use today. And by understanding it and making more advances on how it works and how we can manipulate it, we've made thousands of different inventions, from the ultraviolet light in like the cell lab that kills everything so we can have a clean plate to analyze cells, or from basically like microwaves that allows us to cook something, or the infrared red rays for night vision. Those are all applications that came out of our understanding of electromagnetic radiation or electromagnetic waves. Um, so that's, and the other thing is too, is this is kind of the way we're able to understand like starlight and different types of information from different galaxies. They're all emitting different types of electromagnetic radiation to us, and that's how we observe them in the first place. So and also this is kind of the signal we would look for from alien life. Like they would have to send us some sort of electromagnetic radiation based upon the laws that we know. So there is one more type of way they communicate with us, and that's called gravitational waves, but I'll get into that later on in separate videos. So anyways, that's electromagnetic radiation or electromagnetic waves, and I hope you enjoyed. Thanks, guys.